They are now. Welcome back to the workshop. So today's episode is another episode on the Landrover. So remember back about 2 weeks ago now, we stripped off the swivel hub because the top Ralco bushing was failing and the swivel hub had a huge amount of play in it. We ordered the parts to rebuild it, and we have pretty much everything ready to go. So I thought today would be a good day to get about getting the swivel hub back on the front of the Landy and getting her down on her wheels again. So since you guys have been gone, I did do a little bit of prep work for doing this video. I completely cleaned down the swivel hub outer. So cleaned it down, degreased it, took apart this top pin, checked everything and put it back together in accordance with the manual. Have it all nice and cleaned out and ready for reassembly. To give ourselves or jog our memory, the part that we're replacing is the swivel hub inner. Genie Mac, say swivel hub 3 times fast. It's the swivel hub inner, and there was a couple of problems. One, you can see that the pitting has started to come on the ball, which means all the chrome was coming off, which had eaten the seal and wasn't sealing anymore. The other problem we had, of course, was the Ralco bush. So the Ralco bush is completely and utterly destroyed. If we got a swivel pin, a top swivel pin, and had a look in there, we can see that that's even a brand new swivel pin, and you can see it's flopping around in there. So you could, in theory, just put a new Ralco bush in there, but with the swivel hub being so badly pitted and damaged, we said to the hell with the expense and went and got a brand new swivel hub unit. So we have this lovely swivel hub, Genie Mac, I can't say swivel hub unit ready to rock and roll. So we have to put the Ralco bush in the top, and we have to put a taper roller bushing in the bottom. Then we assemble that into the swivel hub outer inside that way, and we have to set a preload because there's a taper roller bearing on the bottom, and preload is set with a pin here on the top. So we have a pin that comes in through the top, and as you can see, there's a bunch of bushings or shim stock floating around there. We use that shim stock to set a preload on that taper roller bearing. Now, we could be doing this on the Jeep, or we could be doing it here in the workshop. We're going to do it here in the workshop because today, unfortunately, nobody has told the Irish weather that it is summertime and it should be nice and warm and dry. Instead, it is piddling rain. So we'll get as much done here as we can, and then we'll go out to the Land Rover, hopefully between the showers, and get this fitted on. Okay, we're lucky. We have a huge anvil here in the workshop, and we can drive this Ralco bushing in. The brilliance about an anvil is the mass of steel that's underneath it means that any blows from the hammer gets delivered directly into the material. Now, you would have to be careful if you're using an anvil like this because it could mar up the steel the other side. Luckily enough, you know, the inside of these swivel hub housings is not important, and also this is a cast iron anvil. It's a very old anvil. It doesn't have a hardened face surface, so it won't mar up the material. So the secret to putting in any bushing like this is to tap it in squarely, in evenly. Now, we could go up to the press and put this in the press, but I've been told by the powers that be that all that is required is to tap this in with a copper face hammer, and the bush will drift into the housing easily. Okay, well, the powers that be were right. We can hear that nice ring coming off the anvil now. That tells us that the bushing is all the way home. We're going to do the same with the taper roller bearing now. We're going to drive it in. It's worthwhile taking your time starting the likes of one of these taper roller bearing housings, the outers, because they are quite a hard steel and they're going into a reasonably soft casting. So if it picks up either way, it'll drive in, mar the bore in the casting, and it won't sit square. So it's worth just taking your time when you're driving these in. We hear that note change telling us that it has reached the bottom of the bore. You'll see I always use a copper hammer when I'm driving bearings like that. These copper face hammers pretty much cannot damage the surface of the bearing. If you use a steel hammer like a ball peen hammer, it's a hard faced hammer and it'll be hitting a hard faced bearing. It's actually incredibly dangerous to do it because you can actually chip the bearing and that chip can fly at you. And because it's hardened steel at high speed, it can actually penetrate the human body. Best case scenario in a situation like that is a small wound. Worst case scenario, people actually have lost their lives to this, where a piece of steel has flown off a bearing and damaged an artery, and the person has subsequently bled out or been in a very serious way. So when we're in the garage, we try and do things and we try and think ahead of the consequences, so safety is a part of it as well. Copper face hammer like this, I have a toolbox full of these because I use them all the time. Yes, they're not as heavy and they don't give as heavy a percussive blow, but sometimes that's actually a better place to be in than potentially putting yourself at risk, as I said, with a steel face hammer. The anvil has just a brilliant ability to take percussive blows like that. Trying to set this up in the press would actually be very difficult because it's a spherical surface. There's no one nice flat surface to press against. You could make up something to sit in that Ralco housing, but again, that's not a flat surface. It's got a chamfer all the way around on it. So trying to get something to sit nicely there is difficult. You have to make something to allow you to press in the press this way. Whereas the hard surface of the anvil with the copper face hammer just drives in that bearing perfect, and it's a nice simple way. So this is the other side of the bearing and it sits a loose fit here on the pin. I suspect the Landrover engineers, when they designed it, did this so that it was easy for assembly and disassembly. The first thing to do is to grease that bearing. Now, with the kit we get from the Swivel Hub rebuild, there's a liquid grease that goes into this hub through the filler cap and it replaces the oil that used to be on there. It gets filled up in there once the drive shaft is in place. But I'm going to pre-grease the bearing with this really good quality molybdenum based grease that I have here. If you're greasing a taper roller bearing, trying to push grease into the rollers is impossible, and I've seen people doing this. They're trying to push grease into the rollers. How you actually grease a taper roller bearing is with the widest end of the taper, and you put the grease in the palm of your hand. If you're worried about ingress of oil and stuff like that, put a pair of rubber gloves on to protect your hands. But grease like this, your skin is fairly impermeable to it as long as you wash your hands afterwards. So the technique is pretty simple. With the grease in the palm of your hand like that, you push the back of the bearing into the grease. So you're picking off a little bit of grease at a time and you're pushing it into the palm of your hand. And you can see that I'm picking up all the grease on that bearing that way. You can grab off the excess back into the palm of your hand. There's no need to have all the grease in there. And then you can do the same for the front of the bearing. Press it into the palm of your hand. And what you can see is the grease is all squeezing out now, out through the bearing. You can see it's all coming out through the rollers. And that's what we want to happen. That means we know we've got grease in the back of that bearing. It's a messy job. There's no nice way of greasing up a bearing. It's always going to be a messy job. But the difference between greasing a taper roller bearing right and wrong is the difference of a taper roller bearing lasting the lifetime that it should. Okay, so a good quality taper roller bearing, well greased, is a fit and forget item. It doesn't give problems. Okay, want to just clean out the center bore of this bearing because we're going to put a small amount of Loctite, well, bearing fit I suppose, is actually what we're going to put on there. Just to help that bearing stay the course. Now, it's not recommended in the user manual, and again, that's serviceability. That's why they're not recommending that. But me being me, I know that this is going to be very serviceable. So I know I'm not going to change this bearing 100 times. So just a little bit of that bearing locking compound on there. It's a loose fit on that pin. We've cleaned the grease off the inside of that, and we'll just drop that bearing down into place. And what's going to happen now is that the locking compound will go off and it'll go in there. Incidentally, if you do use locking compound like this and you do need to take it apart afterwards, as long as you're not worried about the bearing, all you have to do is heat this with a blowtorch. You get this up to 350-400 degrees, the bearing compound will break down and that bearing will just slide off perfectly, no problems whatsoever. Okay, we're going to start getting the swivel hub installed now. So the first thing to do is to oil this Ralco bush. I'm just using some EP90 here. EP90 is an oil that I use for engine building sometimes. There's a little fiber washer here, which is a kind of a thrust washer, and it sits down the bottom of that Ralco bush, and it's what we thrust load against. A little bit of that EP90 there just to hold it up. Incidentally, the way I have the swivel hub set up here, this is something that I've been doing for years in my workshop, and a few people have commented on it over the years and said it's a good idea. I keep old chucks off of lathes hanging around the workshop because they're great fixture devices. So we're going to build up this hub here, as I said, before we go up to the axle. And to try and hold this hub in the vise, you're going to hold it on this flange, which is a mating surface. It's a surface that is going to have a gasket. It's a sealing surface. So clamping that in the vise is not a good idea. But with the chuck clamped in the vise, then I can just open up the jaws of the chuck to that inner diameter in there, which is just a clearance or a relief for the drive shaft to go through, the half shaft to go through. So using the chuck there to hold it, no problems whatsoever, and it gives me a really strong fixing here that I can build this whole hub up, and it stays at a real nice working height here. It's in a good spot, and I can do all the torquing I need to do on the bolts, check all the preloads, and it holds it well. So I'll get the other half of the swivel hub, which we have just we did the taper roller bearing, and the way these go together is real simple. You just drop the taper roller bearing in at the bottom, that sits there, and then we have what's called the swivel pin. Now on the swivel pin is shims. These are a bunch of shims, and they set the preload of the swivel hub. I have a feeling that we're not going to, these are the shims, these are new shims that just came with it. I have a feeling we're not going to actually have enough shims here. I think we're going to have to use some of the old shims from the original swivel pin. But for the sake of just throwing it together, let's put that swivel pin in, and we'll get this, get 2 bolts in this and get it torqued up, and we'll just see what the preload is like. If the preload is too high, we have to get more shims and put it in here. If the preload is too low, we have to take some of these shims out. I'm going to get 2 bolts, we're going to put them into torque, and we'll see what the preload is like on that taper roller bearing. So what we're doing is setting preload. So see the way that's floating up and down there? As I put the bolts in there and torque that up, I'm going to pull the 2 things together. So that pin is pressing on that washer we dropped into the bottom of the Ralco bush. So as we bolt that, that's pressing that in there, which is pulling the bottom of that swivel hub up into the taper roller bearing. We need clearance in the taper roller bearing so it doesn't bind, but we don't want the taper roller bearing loose so that there's play in the swivel hub. And that clearance is set up here in the shims. I'll show you how we measure it once I get 2 bolts in there. Okay, I've done up 2 of these bolts and I actually stopped doing them up because I could feel this hub getting tighter and tighter, and I knew I was gone beyond the right preload. But just to show you how it's tested, so this is a spring balance, like a fish scale. So if you were into fishing, you'd know what it's like. And the preload that we're supposed to have is, the factory number we're given is 3 to 4 kilos of force it can take. 3 to 4 kilos. So I've marked a line at 3 and I've marked a line at 4, and I know I need to be in the middle of those two to be at the right number. And if we put it here on the end, we can see we swing way past it. Yeah, so it's going way, way beyond the number it should be, and it's still not even moving. So what we need to do to get the right clearance is we need to take out these bolts again, and we need to add more shims. So just as well, I kept the old shims from the original kit because they didn't give us enough shims with the new kit. I'll confess, that wasn't some massive amount of wisdom on my behalf. I've watched a few videos of lads putting these together, and they have said on the videos, keep your old shims because it's very common. The kits themselves don't come with enough shims. So that's someone else's learning has been to my benefit. So we'll just whip out these bolts, and when they're loose, we can add another shim or two underneath there. So we have a kind of a reasonably heavy shim here. So we'll try that one in there and see. The good thing is with a couple of heavy shims in there, we can take out some lighter ones then as we get near it. It's very like shimming the ball joint in a Mini actually. Same kind of principle. You're using shims to obtain preload. Same kind of idea. It's old technology, but very functional and works very well. You can see now why my voice and this setup is just so easy for me, because I'm working at a lovely height here. So that feels better already. I'm feeling like the bolt is bottoming out while it's coming up to torque, and there's still movement in the hub. Still too tight, but we're definitely on the right track. We can just check it with the spring balance quickly, but I know myself by feel. Yeah. So we're getting there though. Just with one shim we're already close. So we'll add another shim here, and we'll get closer again. So messed around another little bit, took out a shim, that one there, put in 2 of the slightly bigger shims from the original pin, and all the shims that came with the pack bar that one. And what that's given us now is it's given us that's just sitting in the middle. Okay, so that's what I want. As we pull that, we're just sitting in the middle, exactly on 3.5 kilograms, which is split right down the middle. You're probably better off getting it there, you know, just at that point where it's in the middle. It's going to loosen off a small bit with a bit of driving, and it'll come to that kind of sweet spot. It's something that we will check in sort of 5,000 or 6,000 miles time. The end of the year we'll do a full service. We'll whip off the 2 links and we'll check these to make sure, and we'll readjust that shim if needs be. It's an easy thing to do in the car. It's 4 bolts, and take off the steering arm, and then that can be done. Next thing to go in is we need to install this seal in here. This seal is the oil wiper seal. It's just a big lip seal. It's just a big spring lip seal, which job is to keep the grease in the hub and keep the muck and dirt from getting in there. The best way I'm told to do this is to put a little bit of grease on the swivel and a little bit of a bit of gasket cement in here, because this isn't a very tight fit and it's actually steel. So a bit of gasket cement in there helps it seal, and a bit of grease on the wiper then helps the seal centralize. Then it's just 3 bolts. One of those bolts is a bolt for setting the maximum turn that you can get on the swivel hub, I'm going to set that on the car. So for the moment, I'll just put it in there loosely. Okay. A few of these bolts in here now to hold it. So we just start by getting a few of the bolts in loosely to kind of hold it in place, and then we will turn the swivel a bit to get the seal to centralize on the swivel hub, because obviously we want to see that the seal is wiping evenly all the way around. And once we have that, then we can cinch down this cover plate, and we can be happy that the seal is centralized and it's sitting where it should be sitting. And then for us, then it's just a matter of doing up those bolts and it's in place. Unfortunately, that's as much as we'll be able to do here in the shop. Then we're going to need to get to the car, or the Jeep should I say, then to centralize everything and get this hub bolted on, and then we can put in the half shaft. Then when we have the half shaft in, we can put on the stub axle. We've put new bearings in the hub. I got a set of bearings local here from eFox Engineering. Big shout out to Craig Fox in eFox Engineering, always coming up with the goods and getting me the bits I need in a timely fashion. Great to have a classic bearing supplier literally 10 minutes from the garage here, and they're one of Ireland's biggest bearing suppliers. Hold a huge stock of new old stock parts as well. So yeah, big shout out to Craig for looking after us during the week and getting us the wheel bearings we needed. So as I said, I just want to nip these bolts first, and then I'm going to move this hub around and just make sure that I'm seeing that seal wiping evenly. So you can see that it's wiping the grease off that I've put on here. So I've smeared grease around here, and I'm looking to make sure I see a wipe all the way around. I want to see that that seal is wiping all the way around. It is doing that in this case, probably a little bit, can't fall any further. It's doing it a little bit less here than it is there. So I'm just going to give the seal a little bit of a tap, just to get it to centralize and to sit down and straighten up. Yep, that got it. That's literally it, just to get that seal centralized. Then once that seal is centralized, we can just keep going then with the ratchet and nip up those bolts. I was surprised that even from the factory, Land Rover didn't put washers behind these bolts, which is unusual. I don't know why that is. Maybe just they reckoned you'd lose washers if you're, you know, in the middle of the African plains trying to get your Land Rover back going again, or something like that. Maybe they weren't with that much forethought. Maybe they were being cheap and didn't put them in it. It just depends on the manual. I seen them in another, the Haynes Book of Lies had written in there that there was washers on them. So it really is, I suppose, just depends on the manual. But I have one of the actual later Leyland manuals on it, or the parts catalogue, and it doesn't have written on it that bearing, so, or that there's washers here. So that's it. Okay, next time you see us, we'll be out at the Jeep. Okay, let's prep the end of the axle here so that we can get the gasket on and we can bolt on the swivel then. So prepping this axle pretty straightforward. Just clean off that gasket surface and any goop or gunk that ended up in there. Just while the swivel hub was off. Yeah, we had a plastic bag over the end of this, so it wasn't just exposed, but it's still worth just cleaning off any goop or gunk that might be there. Put a seal in there. So that's just the drive shaft oil seal, and its job is to stop the axle oil coming through to the swivel hub, which we definitely don't want. Just going to get a soft hammer now and give that a couple of taps. Okay, so we have this gasket in place, we have that tapped in flat. So this guy now has to sit in there, and we want to get a couple of bolts in to hold them in place. So you get one in anyway, and holding. Now we need one side of this needs the steering limiting bracket, and it's held on one of these bolts. This comes over and hits the steering limiter, so we'll have to find that in our bunch of stuff. Okay, the next thing to do is to slip in this half shaft, and it's just a matter of getting it lined up with the splines in the middle of the diff. Now, you know, the usual story. Sometimes it can be easy and sometimes it can be difficult. This time, luckily, it went in easy. So we have a stub plate to go on next, which we need a gasket again. So we'll put a little small bit of gasket goo on here. And this is not really for sealing purposes, this is more to do with holding the gasket. The paper gasket would actually seal this perfectly fine, but we just put a little bit on there just to help hold the gasket in place while we're getting all the bolts lined up. And then once we have that done, we're in the position then where we can get the stub axle on, and then we can get, once we have the stub axle in place, we can put our wheel hub on. And then we're getting close to having this side of things buttoned up. In case you're wondering, I'm not forgetting about this brake pipe. Normally they would be bolted on here, but I'm actually going to change this for a braided brake line, and it'll be literally just here straight onto the back plate with that whole thing gone. So it'll just be a better job. So we're leaving it up there. Okay, I'm just going to go prepare the stub, and then we'll get that stuck on. So I cleaned up our brake back plate. I've put new wheel cylinders in, new shoes, and I've just put the stub on the right way around. So the half shaft outer slides through that hole, and then that sits in, and these bolts then are going to line up with with the holes in the swivel hub outer that we looked at earlier on. So get one or two of these started. That's one there. 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 Now I put a little bit of gasket cement between where that and the back plate goes on, just to try and to prevent any ingress of water coming in from the back into the brake area. Now, it might be a wasted effort because the drum isn't actually sealed here, but it does have a lot of coverage with the wheel. So I'm kind of thinking that just reducing the ingress of water, because everything was very rusty in here. So I'm just thinking that if you reduce the ingress of water, it might just be a better job to help it last a little bit longer. So we're going to spin them up, and once they're all on and tight, then we're at the stage where we can get the drive hub on here, and we can set the preload on the wheel bearing. So the people who supplied the swivel hub are called Britpart, and they provide this, what they call one-shot swivel hub grease pack. So originally the factory spec'd oil in this, I think it was heavyweight like EP90 or something like that in the swivel hub. But over the years it's changed to this sort of liquid grease, and this seemingly is a much better job, and it's a one-shot. You put it in once and it solves the problem. So I have the bung out of the back here, which is this guy. It's a little steel bung. It sits in the back. It's the fill level. Make sure when you're doing this that you have the drain bung obviously closed and done. You don't want to have that bung open. And then it's just simply get this grease pack in there. They give you this very handy little sort of fill nozzle, and you just literally pump that grease in then, and it's going into the hub, and it's kind of liquid It's more liquid than it is grease. And the idea is that once you start driving the vehicle, then the action of the Hardy Spicer flipping over on top of itself one by one gives you the sort of splash lubrication, and it splashes this grease around inside the hub. And well, the idea is that that's the kind of one-shot effect, that there's no need to have to be putting oil in it afterwards. And that's it then. Once that's in there, dispose of that properly, put the bung back in, and that is your swivel hub fitted. So the last major job to do now is to get the wheel bearing, the wheel hub and wheel bearing on and torqued up. So this is the wheel hub. We've stripped this, completely cleaned it, took out the old bearings and put new proper quality Timken bearings in. We've greased them the same way as we showed you. We greased the taper roller bearing in the hub, and I cleaned up this seal surface here. Some of Land Rovers, this is two-part, that this seal ring here can come off, and others it's a one-part. My hubs are this output shaft, it's one part, so that is part of this. So I've just cleaned up the surface. It really wasn't too bad anyway, but I just gave it a clean up just to really kind of bring it back up to a good seal finish. So it's not difficult. These bearings just slide on there. I have the other bearing greased, and you can see, because I'm outside, I keep the bearing back in its original pack. I just loaded it with grease and then put it back in its original pack. You want to be really careful with bearings like this, that on the ingress of dust or dirt, you just do not want them getting into the bearing. So the bearing is properly greased, and it then slides onto there and in to take up the clearance. Now, something that I've always done for years, anytime I'm installing a bearing like this, is just with the hammer and punch, I always just give it one or two blows first before I go putting on just to make sure everything is seated and where it should be. So Land Rovers, the bearing setup in a Land Rover is super picky. They do not like being over tightened, and if you over tighten them, the bearing will fail in like the shortest period imaginable. And these bearings, I can promise you, are a pretty penny. They are not a cheap bearing, so it's important that you do this correctly. So there's a combination of three things. There is the bearing, or sorry, there is the nut that's going to go in and torque the bearing down. There's this very special keyed washer. You can see it has a key in there. So it goes on first and goes against the bearing. Then this nut goes on after it, and that nut has the job of preloading the bearing, bringing tension onto the bearing. How much tension? The way we measure the tension is using a dial indicator gauge. You always see me with dial indicator gauges, but they have a job. So before we put the indicator on, we'll get our where have I put it? We'll get our adjustable C-spanner here, or water pump pliers, and we're going to give this a nip up just to seat everything. The same as with the punch. You've seen me with the punch before. We're just giving that a nip up to seat everything, and then we'll bring it back down to the clearance. This is something that you shouldn't miss when you're putting in any kind of taper wheel bearing. So see, that bearing now is way overloaded. Okay, I've loaded it up here. So we can back this nut off then. And what we'll do then is we'll set our dial indicator up. So we have our magnetic based dial indicator. Sit them on there. And we want to get the indicator onto that inner stub shaft. Now outside, it's not going to be possible for you to see the readings on this dial indicator, so you're just going to have to trust me. The measurement from the factory, or the measurement from the factory that we're given by Land Rover, is 2 to 4 thousandths clearance. Now, when we put the second nut on with the washer and torque it, it's going to reduce that clearance. So we have to be a little bit coy about how we do it. from memory, the way to do this is to set it at the higher clearance, then torque the nut down and then check it again, and it should be at the lower clearance, at the 2/1000s. I want it between 2 and 2.5 thousandths of an inch. That's what I'm going for, because I just know that that is going to be the right number. So I start by just bringing it out the way, and then I'll push it in the way to get my 0. So I've 1/1000th there. So I'm going to let another tiny bit off that. Okay, I've got 2/1000ths there. Press it in and then bring it back out again. Okay, 2.5 thousandths there. So we now have to get our lock and washer, wherever I've put that now. Here. So this is a lock tab, and when we're happy with our preload, the way our lock tab is going to work is one half gets bent over a flat of the nut on the inside, and one gets bent over a flat of the nut on the outside. So we bring this guy on, we tighten him up. And then he will preload on the nut on the inside. So we had a bit of messing around to do to get that where it needs to be, but I have it now at the point where I have very little roller resistance, and I checked it and I have 2.5 thousandths end float, which is right in spec, or it's right where it needs to be. It's right where the factory book says it should be. So last couple of bits now to go on. That is the drive flange. So that's connecting the drive shaft to the hub, and it just has a couple of bolts that hold it in place, and a gasket. Now, last bolt in, we'll torque these when the wheel is on properly, because they're just the driving flange bolts and they're hard to hold. When you could put a bar in there, but they're easily accessible with the wheel on, so we'll torque them then. Okay, now we've got a little spacer washer that goes in there, and a castle nut. Well, it's not exactly a castle nut, but it has the same sort of outer appearance as a castle nut. Now this nut doesn't have to be done up to huge torque. There is a special style spanner to tighten those, but actually all you need to do is bring them on to the next castellation, which I think is going to be that one there. Yeah. Another little top. Perfect. And we'll get split in for that. Okay. So split them in there. And then we have a grease cap to go on that guy. And then the drum that we machined back the last day, you'll remember this from the last turning video we had, where we got these drums. These not fitting now. our drum from the last day, and then they have a couple of, sure they're in the right spot. So a little bit of adjustment to do there, and we have 2 locking screws to go in there, and then put on the track control rod. We have replacement rods for that now. That's going to go on with the new steering arm, and that will be the hub finished. I hope you guys enjoyed coming along with me for this video. We're getting the Landy back serviceable, I suppose, and get her back on the road. As I said, Landy will be a project that is going to be continually worked on the channel. The aim at the moment is just to get the car driving, get it functional, get it back as a serviceable vehicle to work for the shop. Then over time we'll do little bits on the vehicle all the time as they crop up and need to be done. Another swivel hub has to be done that side, the back plate has to be rebuilt and has to be fixed up. Bodywork, all that sort of stuff. Hope you enjoyed the video. Ugh. You can cut that. Hope you enjoyed the video. Anybody new to the channel, you are most welcome. Have a look around. We do lots of other videos. We do machining videos. We do videos on the classic Mini and also some other videos on the Land Rover. To those of you who have stuck it out and watched the video, thank you so very much. Don't forget to hit the like button. It helps the videos out and it helps the channel to get noticed. To everybody who comments, thank you so much, and I look forward to reading them all. Sorry, I'm a little bit slow at the moment about replying to comments, but we've had a huge influx of subscribers, and it is getting a little difficult for me to get to all the comments, but I do love reading them, so please don't stop commenting, keep leaving them there. I love to hear them. Other than that, guys, don't forget, hit that subscribe button if you're new, and I'll see you on the next one.